Okay, so in this module, we are going to be calculating pressure volume work. So there's two types of work. There's chemical work, and then there's mechanical work. Now we're going to be focusing on mechanical work, and that's the pressure volume. Now again, so we're focusing on the work. So PV work is caused by a volume change against an external pressure. So we have a volume change against an external pressure. So by changing this volume, so here we have a smaller volume, here we have an expansion. Now what happens is, in order to change the volume, it has to push against a force of our P atmosphere. So for this to expand, it's pushing against this force. Now this lowers the energy of our system. So our energy leaves the system as work. So work is being done. Work is being done by the system. And if you recall from the last lecture, work is negative when work is being done by our system. Now there's a formula that we're going to have to use, and there is also a conversion factor. So the formula that we're going to use is our work of our gas is equal to the negative P external delta V of our gas, so our change in our volume. So this is the formula that we're going to focus on. And then the conversion factor, our conversion factor is going to be 101.3 joules, liters, atmospheres. So we'll need these for the next couple of examples. So let's go ahead and take a look at our first example. Our first example is how much work in joules is involved when 0.225 moles of nitrogen at a constant temperature of 23 degrees Celsius is allowed to expand by 1.50 liters in volume against an external pressure. So if we see the word expand or compress, so a change in volume, so this is our delta V, and an external pressure, then we know we will just use that formula. Now the formula again is work equals minus P delta V. So in these problems, you don't have to remember the sign convention for work. It'll work out in the formula. But for other conceptual problems, you're going to want to remember the sign convention for our work. So let's go ahead and plug these in. So we know that work equals minus 0.750 atmosphere. So that is our external pressure. So here's our P external. And then our change of V, it expanded by 1.50 liters. So we're going to go ahead and just multiply by 1.50 liters. And that's going to give us 1.125 liters times atmosphere. Now here, if we look at sig figs, I'm going to mark that for later. So now we have liters times atmospheres in work. If you recall from before, that's going to be energy, right? So we want joules. Well, how do we get joules? We want to use that conversion factor. So 1.125 liters times atmosphere. And then we're going to go ahead and use the conversion factor from earlier. Liters atmosphere, 101.3 joules. And that equals minus 114 joules. So here, work is negative. And the system is doing work on our surroundings, so that should make sense. So our system is doing work on our surroundings. Just another way of saying work being done by the system. Okay. So that's one example. Let's look at another example. So the air within a piston equipped with a cylinder absorbs 565 joules of heat and expands from an initial volume of 0.10 liters to a final volume of 0.85 liters against an external pressure of 1 atm. What is the change in the internal energy of the air within the piston? Now, this example, we're going to have to go ahead and now put together what we learned before about our internal energy and how that relates to heat and work. So let's draw some pictures to describe what's happening. So here we have 0.10 liters, and we know, again, we have an expansion. We have an expansion to 0.85 liters. Now our volume increased, right? So we know our work is going to have to be negative. Okay. Now, what else are we given? We're given that our P external is 1 atmosphere. And then here it says we have a cylinder that absorbs 565 joules of heat. So remembering our sign convention before, heat is Q. And if it absorbs, that means it's going to be positive, plus 565 joules. And then we know our change in volume is our final minus our initial, so 0.85 liters minus 0.10 liters. So we're going to get 0.75 liters. So let's write the formulas we know. W equals minus P external times delta V, and we know our internal energy is equal to Q plus RW. Okay, so now let's go ahead and start figuring out what we need. So I know we need to find our internal energy. So it wants to know the change in the internal energy, and to do that we need Q plus W. Now Q we have, that's 565 joules, so we have to find work first, and then we will find our internal energy. So let's find our work. So work equals minus 1.0 atmosphere times 0.75 liters. So that will give us negative 0.75 atmosphere times liter. And then we'll use our conversion factor, 101.35 joules per liter atmosphere. So when we get this, we're going to get negative 75.975 joules. And hold that for our sig figs. So now we can go ahead and plug it into our formula to find delta E. So delta E is going to equal a positive 565 joules plus our negative 75.975 joules. And here, because it's adding, we'll take a look at decimal places, right? So in the end, we should have no decimal places, correct? It shouldn't be to the tenths. So we have the 2 sig figs here, but we're cutting it off at the 5, so 489 joules would be our answer. And again, it's a positive 489 joules. Okay, so we'll see how this works. Uploading to Canvas. All right, we're done with pressure volume work.